Hello, welcome to part 2 of solving equations with logarithms. The other day we learned how to solve exponential equations where we introduced a logarithm to the problem. But today we're going to take a look at how you solve problems that already have logarithms in them. And the big idea today is we need to figure out, do we have a problem that involves duh, or do we have a problem that's going to involve the definition of a logarithm? And let me dive into this a little bit more. So we'll come back to this page in just a second. But this is a property of logarithms. It has a technical mathematical name. It's called the one-to-one property of a logarithmic function. But I like to call this the duh property. And this is basically what it says. Suppose you had log base 4 of x, and it's equal to log base 4 of this number. And what a beast this number is. 312.253 with just the 5-3 repeating. And I asked you to solve that for x. Well, I would imagine at first you'd be a little frightened because that number is so big. But if you really thought about it and you took a good hard look, I'm sure in the back of your mind you would hear yourself saying, well, duh. If log base 4 of this is equal to log base 4 of that, then doesn't it just make sense that this is going to have to equal that? And again, in math, we call that the one-to-one property of a logarithmic function, but I just call it duh. Of course it's true. So some of the problems we have today are problems that we can use this whole concept of duh on. And let's take a look at problem number 1, for instance. So I see I have on the left-hand side a single logarithm, and on the right-hand side I also have a single logarithm, and both logarithms have a base of 3. And when you look at this, I think you say, well, if a log base 3 of x equals a log base 3 of 5, well then, duh, x has to be equal to 5. Those would have to be equal for this to be true. Now, that's a really easy problem. Let's take a look at a problem that's a little bit more advanced, like problem number 2. Well, problem number 2, I'm not quite ready to use my duh property. And the reason I can't is this 2 is right here hanging out in front of the logarithm. And so because the 2's there, I don't really have that one-to-one characteristic that I'm looking for. I need to find out how I can get that 2 out of there. And one thing you might try doing is dividing both sides by 2, but I don't think you're really getting it out of there. You're just moving the 2 from the left to the right. But here's where the fact that these are logarithms really comes into play. Remember that power property of logarithms that says if you take a log of a number to a power, you can grab that power and you can bring it down? Well, I'm going to use that same idea but in reverse. And that's that if I have a number times a logarithm, I can take that number and I can bring it up. And so this ends up becoming log base 7 of x squared. See how that 2 was pulled up into the exponent? Equals log base 7 of 36. And a lot of times in the past we've used the power property to bring the 2 down. Now I'm just reversing it. And now that we have a single log base 7 equals a single log base 7, I can use the duh property and say, well, this has to equal that. And so now that I have these things equal to each other, I think I have this kind of in a prettier way here. I can solve this. Whoops. You shouldn't see that. What I can do is I can solve this by taking the square root of both sides. But when you take the square root of both sides, you have to remember to put in that plus or minus. And so when I put that plus or minus in there, I get x is positive or negative 6. But here's a problem. And you may not remember this, But we have this rule about logarithmic functions, and that rule is simply that this number inside a logarithm, this number right inside the logarithm, has to always be a positive number. And when you're solving problems involving logarithms, it's possible, through no mistake of your own, you get what's known as a false root or an extraneous solution. Something that mathematically you didn't make a mistake on and showed up as an answer, but when you put it back into the problem, it doesn't work. And so when I put a positive 6 in, that's fine. X can be positive 6. But when I try a negative 6, this number inside the logarithm can't be negative. So it turns out I have a false root, and x is equal to just 6 in this scenario. Let's take a look at another problem. Whoops, we've already talked about this. Let's take a look here. So here's another problem. It has a lot of logarithms in it. And so seeing all these logarithms throughout, I get the feeling that this might become one of those duh problems. But I'm not ready for a duh yet. You see, duh only works if you have a single log equal to a single log. And I don't have that here. And so I'm going to have to go back into my logarithm properties and find out how I can condense this into a single log. And you might think of the product property. Log base 8 of x plus log base 8 of 3 is simply log base 8 of x times 3, or 3x. And so I can unify the left-hand side using the product property. And now that I have log base 8 of this equals log base 8 of that, clearly this is going to have to equal that. And so I can make 3x equal 12. And then just solve this by dividing both sides by 3 and get x equals 4. Now again, with logarithmic equations, you want to check and make sure that that 4 works. So I go back up here and I put a 4 in for x, and since that's a positive number, everything is fine. Works out great. Let's try another problem. Let's take a look at this one down here. Again, a single logarithm equal, whoa, this is not a single logarithm. So I'm going to have to use the product property again to join these two logarithms together. So that becomes log base 4 of 2x minus 3. And using the product property, I have to multiply this x by x minus 2, and I distribute it. Now I have a single log base 4 equals a single log base 4, so I can use duh and set whatever's inside the two logarithms equal to each other. Ooh, we've got a quadratic, which means we're going to have to move everything over to one side. X squared minus 4x plus 3, everything moved over to the right, and we're going to have to factor this. So we factor this, and then we solve. The quantity of x minus 3 times the quantity of x minus 1 is equal to 0. That means x must equal 3 or 1. Now, again, we want to go back and we want to check. If I put a 3 in for x, this is a positive number. Great. This becomes a positive number. 3 minus 2 is 1. And this is a positive number. 2 times 3 minus 3 is 3. Works out great. Let's put a 1 in. When I put a 1 in here, that's a positive number. When I put a 1 in here, when I put a 1 in here, that's a negative. Remember, you cannot have a negative number inside the logarithm, so I'm going to have to throw that 3 out. That's one of those extra or extraneous solutions. Let's see what's next. Oh, heavens, look at this. This is not a duh problem because I have a log base 3 on the left, but I have no logarithm on the right. So this actually becomes a different strategy. We're not going to use duh, we're going to use the definition of a logarithm. So in this case, if we had, say, and I'm just making up a problem, log base 4 of x equals 3, logarithms can be pretty tough to understand. And so if you ever have a situation where you're dealing with a logarithm and you can't figure out what that should be, you have a luxury of taking that and rewriting it in exponential form. Remember, my base is 4, my number is x, and 3 represents my exponent. So I can say this is 4 to the third power equals x. So 4 times 4 times 4, 16 times 4, 64 is what x is. So when I come over to this problem that we were just looking at here, this is a really good time to say, well, I can't use the, so I'm going to use the definition. I'm going to take this base, this number, and this exponent. Remember how we convert from logarithmic to exponential form. The base is 3, the exponent is 6, and that should equal x. And so x turns out to be 729. Again, check your work, make sure that that's an okay answer. And let's try another one. I happen to have another one right here. Again, you look at this problem and you think, well, log base 2 of this equals just 5. There's not another logarithm over here, so this is not a duh. We're going to have to use the definition of a logarithm. Again, base is 2, the number is 3x plus 2, and the exponent is 5. So if I rewrite this, converting from exponential to logarithmic, from logarithmic to exponential form, I get the base of 2 raised to the 5th power equals 32. Good time to count on your fingers. 2 to the 5th is 32. I move my 2 over, and I end up getting x is 10. And before I'm done, I'm going to take that 10 and plug it in and make sure the number inside the logarithm is indeed positive, which it is. Let's take a look at one more. Here's my last problem. And again, I see that I have logarithms on one side, but no logarithms on the other. So this won't turn out to be a duh, but it will turn out to be a definition. But before I use the definition of a logarithm, I don't like that these are split apart. So I'm gonna condense these together using the product property. So the product property says when you add separate logarithms, you multiply what's inside. So I took log base 2 and I took this x minus 1 times x minus 3 and I expanded it out to give me that. Now that I have a single logarithm equals a number, I can use the duh property. 2 is my base, 3 is my exponent, so 2 to the third equals the stuff inside the logarithm. Ooh, and it's a squared term. So after cleaning up 2 to the third, I'm going to move everything to one side. I like to keep my x squareds positive, and I'm going to try to factor this. Lucky for us, it does factor. It factors into the quantity of x minus 5 times the quantity of x plus 1. So that gives me x is equal to 5, or x is equal to negative 1. And that was a lot of fun work, where we used the product property to condense a logarithm. We rewrote it in exponential form. We had some factoring. What a great problem. But we're not done. We're not done until we go back and we check our answer. When x is 5, I put a 5 in here. 5 minus 3 is 2. That's a positive number. That's okay. I put a 5 in here. 5 minus 1 is 4. That's also a positive number. I'm okay with that. When I put a negative 1 in for x, negative 1 minus 3, that's a negative number. I'm going to have to throw that out. And again, it's not because we made a mistake in doing the math. It's that this answer was an extraneous solution. It doesn't work. And so my final answer is x equals 5. Well, I hope this helped. Good luck with your homework.